Hello everyone, this is Ajay and you are welcome on my YouTube channel, which is Math Cafe. So this one is the part 8 of our topic, which is matrix. So this video is all about symmetric and skew symmetric matrices. So first one we will pick symmetric matrix. Alright, so let's see some definition of symmetric matrix. So a square matrix is called symmetric matrix. A square matrix A is called symmetric matrix. If A is equal to A transpose. Alright, A is equal to A transpose. If a square matrix is written in this form, then A will be a symmetric matrix. So let's take an example here. If A is written in the form of A11, A12 and A13, A21, A22 and A23, A31, A32 and A33. Alright. If I consider that A is equal to A transpose, alright, so A is the given matrix, that is A11, A12, A13, A21, A22, A23, A31, A32, A33, alright, is equal to A transpose. And how will we get A transpose? Just interchanging all the rows and columns. So row number 1 will become column number 1. So A11, A12, A13, A21, A22, A23, A31, A32, A33. Alright. So this is A and this is its transpose. In algebra of matrices, we have already studied about equality of matrices. So these both matrices are equal, so its corresponding elements will be equal. Alright, so A11 is equal to A11, it is already equal. So A12 will be equal to A21. In this case, A12 will be equal to A21. Alright, and A13 will be equal to A31. A13 will be equal to A31 and A21 is equal to A12. We have already taken this case, and A22 is equal to A22. This is already equal, and A23 will be equal to A32. Alright, A23 will be equal to A32 and A31 will be equal to A13, and we have already taken this case. A32 will be equal to A23 and we have already taken this case. So A33 will be equal to A33. This is already equal. Alright, this is already equal. Alright, so here we find three conditions. If a matrix of order 3 cross 3 is a symmetric matrix, then A12 should be equal to A21, A13 should be equal to A31 and A23 should be equal to A32. Alright, let's observe here that if this is a 3 cross 3 matrix, this square matrix is a symmetric matrix, then A12 should be equal to A21, or A13 should be equal to A31 and A23 should be equal to A32. These terms are equal, then this matrix will be called a symmetric matrix. Alright, let's take here another example. If any matrix A is written in the form of let's say A, B, C, X, Y, Z, P, Q, R. Alright. If A is a square matrix, A square matrix is a symmetric matrix. Then, so we are going to see here when this matrix will be a symmetric matrix. Alright, when A11, A12 will be equal to A21, A13 will be equal to A31 and A23 will be equal to A32. Alright, then I can write that B should be equal to X, C should be equal to P, and Z should be equal to Q. Right? B should be equal to X, C should be equal to P, and Z should be equal to Q. Then the given matrix is a symmetric matrix. Let's take another example here. If any matrix A is written A, let's say 0, 3, 0, B, 4, let's say 3, 4, and C. So in this question we need to verify that the given matrix is a symmetric matrix or not. So the given matrix is a symmetric matrix or not. Alright. So let's proceed with the solution. If this matrix is a symmetric matrix, then this term should be equal to this term, alright, and this one is A13 should be equal to A31, okay, these two terms are equal, and A23 should be equal to A32, also these terms are equal. So I can easily say that this given matrix is a symmetric matrix. Hope you understand this. Let's see the another definition, which is a skew symmetric matrix. Alright, so second definition is skew symmetric matrix. So A square matrix A is called skew symmetric matrix if A transpose is equal to minus of A. A square matrix A is called skew symmetric matrix if A transpose is equal to minus of A, or A is equal to minus of A transpose. Let's take an example here. If a matrix A is written A11, A12, A13, A21, A22, A23, A31, A32, A33. Alright, it is given that this matrix is a skew symmetric matrix, so I can easily say that A transpose will be equal to minus of A. Alright, how we will obtain A transpose? I will just interchange all the rows and all the columns of matrix A. So that will become A11, A12, A13, A21, A22, A23, A31, A32, A33. This is transpose of a matrix, given matrix A. Alright, that is equal to minus of given matrix A. A matrix is A11, A12, A13, A21, A22, A23, A31, A32, A33. Alright, so we are using here algebra of matrices, so corresponding elements will be same. So A11 will be equal to minus of A11. Alright, so A11 will be equal to minus of A11, and A21 will be equal to minus of A12. A21 will be equal to minus of A12, and A31 will be equal to minus of A13. A31 will be equal to minus of A13. Again A12 will be equal to minus of A21. We have already taken this case. A22 will be equal to minus of A22. So A22 will be equal to minus of A22. Again A32 will be equal to minus of A23. A32 will be equal to minus of A23, and A13 will be equal to minus of A31. We have already taken this case, and A23 will be equal to minus of A32. We have already taken this case, and A33 will be equal to minus of A33. So A33 will be equal to minus of A33. If you notice here that in this equation we will get A11 will be equal to 0. Alright, in this case we will get A22 will be 0, and in this case we will get A33 0. Alright, so if a matrix is a skew symmetric matrix, then the necessary condition is that its all the diagonals should be 0. Alright, all the diagonal elements should be 0, and all the non-diagonal elements, what about the non-diagonal elements? A12 should be equal to minus of A21, A13 should be equal to minus of A31, and A23 should be equal to minus of A32 if A is a skew symmetric matrix. Alright, let's take another example here. If any matrix A is given in the form 0 A B minus A 0 C minus B minus C 0, so we need to verify that is it a skew symmetric matrix. Alright, so if it is a skew symmetric matrix, then first necessary condition is that the diagonal element should be 0. So as we can see, it's all the diagonal elements are 0. Alright, and the second necessary condition is that A12 should be equal to minus of A21. So this is equal. Alright, and A13 should be equal to A3 minus of A31. Alright, this is also equal, and A23 should be equal to minus of A32. This is also equal. So I can easily say that this is a skew symmetric matrix. Alright, let's see another example here. If it is given A is of 2 cross 2 order matrix and determinant value of A is 2, then we need to find the value of, let's say, determinant of A transpose, determinant A, determinant and A. Alright, we need to find the value of this expression. Alright, so let's proceed with the solution. So here determinant A is 2. So as we know that determinant of A transpose can be expressed as determinant of A. So here given expression is determinant of A transpose, determinant of A and A, whole determinant. Alright, so A transpose can be expressed as determinant of A multiplied by determinant of A and multiplied by A. Alright, so determinant of A is given 2, so 2 multiplied by 2 will become 4, so 4 of A determinant. Alright, so we need to finally obtain the value of determinant value of 4A. So I can take 4 outside of this determinant, so this will be in the form of 4 raised to n, where n is order of the matrix, which is 2, so 4 is square, and we will be left with determinant value of A. Alright, so 4 square is 16 and determinant value of A is given in the question, that is 2. So finally we will get the value of this expression 32. Hope you understand this. So let's move to the next example here. In a matrix A which is of order 3. Alright, and if it is given the determinant value of a matrix A is minus 1, then we need to find the value of an expression is given here, determinant of A transpose and determinant of 2A and A. Alright, we need to find value of this expression. So let's proceed with solution. So the given expression is determinant value of determinant of A transpose, determinant of 2A and A. Alright, as we know that determinant of A transpose can be expressed as determinant of A, and we can take 2 outside of this determinant, so this will be in the form of 2 raised to n, where n is order of matrix, that is 3. So we will be left with determinant of A and finally A. Alright, so determinant of A is given minus 1, so their determinant of A are 2 times, so minus 1 whole square multiplied by 2 raised to 3 and multiplied by determinant A. Alright, so minus 1 square will become 1 and 2 raised to 3 is 8, so 8 into my matrix A. Alright, again I can take 8 outside of this determinant, so this will be in the form of 8 raised to n. N is order of the matrix, that is 3, multiplied by determinant value of A. Alright, so 8 multiplied by 3 will become 512, and determinant value of A in the question given -1. So finally we will get the value of this expression as -512. Alright, hope you understand this. Let's take another example here. It is written in the question that if a matrix is given x, z, -3 and y, if A is a skew symmetric matrix, if A is a skew symmetric matrix, then find all the variables x, y and z. Alright, so let's proceed with the solutions. As we know that if this matrix is a skew symmetric matrix, then its all the diagonal elements should be 0. So first necessary condition is that x is equal to 0 and y also should be 0. Alright, so we obtained the value of x and y. What about the z? Z should be equal to minus of -3. Alright, so z should be equal to minus of -3. So here the value of z is 3. So finally we obtained the value of x as 0, value of y is 0 and value of z is 3. Hope you understand this. So let's move to the next example. It is given in the question that a matrix is, let's say x, z, 3 minus z and y. Alright, and if A is a symmetric matrix, A is a symmetric matrix, then we need to find the value of all the variables x, y and z. Alright, so let's proceed with the solution. If this given matrix is a symmetric matrix, then we have no condition for diagonal elements, so x and y can be anything. So x and y can be anything, any real number. Alright, what about z? So z should be equal to 3 minus z. So z should be equal to 3 minus z. So 2z will become 3 and value of z we obtain 3 by 2. Alright, so value of x can be anything, value of y can be anything, and value of z is fixed, that is 3 by 2 if given matrix A is a symmetric matrix. Alright, hope you understand this. Let's move to the next example here. If it is given that we need to prove A plus A transpose is a symmetric matrix. Alright, so we need to prove that A plus A transpose is a symmetric matrix. Let's say A plus A transpose is another matrix B. So B is A plus A transpose, and we need to prove that B should be equal to B transpose, because B is a symmetric matrix we need to prove. Alright, let's find B transpose. So that is A plus A transpose whole transpose. So how will we solve this expression? I will just put transpose on each of the expressions. So we will get A transpose plus A transpose whole transpose. Alright, so A transpose is as it is, plus A transpose transpose will become matrix A. Alright, that is nothing but A plus A transpose, and this is B transpose. So B transpose will be equal to A plus A transpose is already B. So B plus B transpose is B. So that's what we needed to prove. Alright, so let's move to the next example here. If it is given, again we need to prove A minus A transpose is a skew symmetric matrix. Alright, so let's proceed with the solution. Let's say A minus A transpose is another matrix B. So B is A minus A transpose. And what we need to prove? We need to prove that B transpose should be equal to minus of B. We need to prove B transpose should be equal to minus B, because we need to prove that B is a skew symmetric matrix. For a skew symmetric matrix, if we take a transpose of matrix B, that should be equal to minus of matrix B. Alright, so let's find here B transpose, that will be equal to A minus A transpose whole transpose. Alright, so I will solve this expression as A transpose minus of A transpose again transpose. So A transpose will be as it is minus A transpose of transpose will become A. Alright, if I take minus common from these two expressions, that will become A minus A transpose. So this is B transpose. Alright, so here B transpose will be equal to minus of, as we know that A minus A transpose is equal to B. So this expression is B. So we prove that B transpose is equal to minus of B. So matrix B, that is A minus A transpose, is a skew symmetric matrix. So let's move to the next example here. It is given in the question that if A is a symmetric as well as skew symmetric, if A is a symmetric as well as a skew symmetric matrix, then we need to prove that A is a null matrix. Alright, so let's proceed with the solution. It is given in the question that A is a symmetric matrix. If a matrix is a symmetric matrix, then A transpose will be equal to A. Alright, and also we have been given that A is a skew symmetric matrix. So if a matrix A is skew symmetric matrix, that means A transpose will be equal to minus of A. Let's say this is equation number 1 and this is equation number 2. So from equation number 1, it is given A is equal to A transpose, and in the equation number 2 it is given if I multiply minus 1 on both sides, then A will be equal to minus of A transpose. If I add both the terms, then A plus A will become 2A, and A raised to T and minus of A transpose will become 0 matrix. So finally matrix A will be a 0 matrix. That's what we needed to prove. Hope you understand this. Let's move to the next example here. In the next question, we need to prove that determinant value of odd order skew symmetric matrix skew symmetric matrix will be 0. Alright, so let's proceed with the solutions. So in the question, it is given that we need to find the determinant value of odd order skew symmetric matrix 0. So it is given in the question that if A is of n cross n order, here n is odd. Alright, that is given in the question. If A is a skew symmetric matrix, then I can write A transpose is equal to minus of A. Alright, if I take determinant on both sides, then determinant of A transpose will be equal to determinant of minus A. Alright, so as we know that determinant of A transpose will be equal to determinant value of A, and determinant value of minus a. So I can take minus 1 out of this determinant. So minus 1 raised to n. N is odd. Alright, so minus 1 power odd, and we will left with determinant value of a. Alright, so determinant of a will be equal to minus 1 power odd will become minus 1. Alright, so determinant value of a. So finally 2 times of determinant value of a will be 0, and finally determinant value of a will be 0. That's what we needed to prove. So let's take another example here. If it is given in the question that if A and B are symmetric matrices, if A and B are symmetric matrices, alright, then we need to prove that first we need to prove that A plus AB plus BA, AB plus BA is a symmetric matrix. Alright, in the second part we need to prove that AB minus BA is a skew symmetric matrix. Alright, so let's proceed with the solutions. So first of all, we will see here what is given to us in the question. It is given that A and B are symmetric matrices. So A transpose will be equal to A, alright, and B transpose will be equal to B. It is given in the question. In the first part, we need to prove that AB plus BA is a symmetric matrix. Let's say AB plus BA is a matrix C, and we need to prove that C transpose will be equal to C if C is a symmetric matrix. Alright, so let's proceed. If we obtain C transpose, that will become AB plus BA whole transpose. Alright, so I will just put transpose on both of the terms, so that will become AB transpose plus BA transpose. Alright, AB transpose is nothing but B transpose multiplied by A transpose plus A transpose multiplied by B transpose. Alright, so B transpose is B, it is given in the question, and A transpose is A, plus A transpose is A and B transpose is B. So I can write it as AB plus BA, AB plus BA. Alright, so here AB plus BA is matrix C, so C transpose will be equal to C. Alright, so AB plus BA is a symmetric matrix. We have proved it. In the second part, we need to prove that AB minus BA is a skew symmetric matrix. So let's see, this is matrix D, which is AB minus BA, and we need to prove that this is a skew symmetric matrix. So we need to prove that D transpose will be equal to minus of D if D is a skew symmetric matrix. Alright, so we obtain D transpose, that is nothing but AB minus BA whole transpose. Alright, so that will become AB transpose minus BA transpose, so that will become AB transpose minus BA transpose. Alright, so AB transpose is nothing but B transpose A transpose minus A transpose B transpose. Alright, so B transpose is given in the question, it is B, and A transpose is A minus A transpose is A and B transpose is B. Alright, so if I take minus common, then we will be left with AB minus of BA. Alright, and AB minus BA is matrix D, so this is minus D, so D raised D transpose is minus D. That is what we needed to prove. Alright, so D is a skew symmetric matrix. We have proved it. So hope you understand this lecture. If you still have any doubt, you may ask in the comment section. So see you soon in the next video. Till then, bye, take care and keep learning.